Greetings to everyone watching this video. The topic for this video is why linked list, a widely used data structure. But before we talk about linked list, let's know something about arrays. Array is a linear data structure, which means that data in array is stored sequentially or linearly. It is static in nature. Memory for array is reserved right when right when its size is declared in the program. It has contiguous memory allocation, which means that memory for array is reserved consecutively one after the other. Elements can be accessed easily in array, that is in constant time, because the elements are indexed. Let us take example of an array with size 6. Since the size of this array is 6 and the indexing begins from 0, it will be up to 5. Suppose this is the data that we have stored in our array. Now let us consider the address of our first element is 1000. Let us suppose that in our computer architecture, integer takes up 4 bits. So this memory address for the next element of array will be 1000 plus 4, which is 1004. And so on, the data will be stored in the array. Now what are the shortcomings of array? The size of array is fixed. Resizing an array is a complex process. Wastage of memory happens if all memory blocks are not used in the array. Let us consider an array with size 6 which has some data already stored in it. Suppose we want to insert a new data element in between any particular um, indice of the array. Now, suppose this is the element that we want to store in between the array. Now, since the array size is full, we can't directly insert it by performing shifting or any other process. We will have to consider a new array and copy all the data into that array and then insert this element at our desired position. Even if this array was half empty, we would still have to perform shifting, which is again a complex process. This is when linked list comes into play. Linked list is a linear abstract data structure. Keep in mind that array is not an abstract data structure. Linked list is dynamic in nature, which means the size of linked list can be decided by the user right at the runtime. It is made up of nodes. Nodes come together to form linked list. This is what a node looks like. It has data stored in it and a pointer that points to the memory location of the next node. Let us consider a linked list, a very simple example of singly linked list. This node has some data stored in it and the pointer points to the next node. Similarly, the pointer of this node points to the next node. This keeps on going until we reach the last node because the pointer of the last node points to null. Now, why linked list? Or basically the comparison between array and linked list. Array has fixed size, while linked list has dynamic size, which gives us the freedom to decide size of linked list at runtime. Insertion and deletion in array is a complex process because either we will have to perform shifting or we will have to copy the data into a new array. While in linked list, insertion and deletion is quite efficient. Random access in array is easy because of indexing. Now this is a plus point of array as random access in linked list is not easy. We will have to perform traversing using a new pointer. In array, sequential access is faster because the memory is stored in contiguous memory locations, while in linked list, sequential access is slower. In array, memory wastage occurs when the array is not completely filled, while in linked list, no wastage of memory occurs. So this was about the topic. Thank you.